This is an object in projectile motion. An object in projectile motion is only subject to acceleration of gravity, and its path is called a trajectory. A falling object is a simple one-dimensional type of projectile motion. The most important fact to remember when solving a projectile motion problem is that motions along perpendicular axes are independent of each other, and we can solve them separately. When we are solving a projectile motion problem in 2 dimensions, we first break this motion into 2 components, horizontal and vertical. We assume that air resistance and friction are negligible. And with this assumption, we essentially simplify the projectile motion into 2 separate motions, one with constant acceleration along the y-axis, and another motion along the x-axis with constant velocity. The constant acceleration along the y-axis is our gravitational acceleration, g, or negative g, because it is pointing in the negative direction. So when looking at this motion, we can essentially assume that 2 different motions completely independent of each other is happening at the same time. So one motion is a ball going up and then coming back down, only affected by the gravitational acceleration. But this is an object that has constant acceleration and is only moving in the y direction, going up and then coming back down. And then completely independent of this motion, we can assume that we have another motion in the x direction. Now, this object is moving with constant velocity and no acceleration. Now let's assume that this ball is moving in a projectile motion with velocity v and forms the angle theta with the x-axis. How do we find the appropriate kinematic equations for this motion? So this is the ball. It has the initial velocity v, and it forms a theta angle with the x-axis. To find out which kinematic equations we can use for this motion, first step is to break down this motion into horizontal and vertical components, as I mentioned before. This would make our job much easier because we can treat the motion as 2 independent one-dimensional motions. And we can write the kinematic equations for each motion separately. As a reminder, I'm going to write down the kinematic equations for a motion with constant acceleration. To find the equations for horizontal and vertical motions, let's first specify the position, velocity, and acceleration for each motion. We will show the position along the x-axis with the symbol x, and the position along the y-axis with the symbol y. We will show the velocity along the x-axis with the symbol vx, and the velocity along the y-axis with the symbol vy. There is no acceleration along the x-axis, and the acceleration along the y-axis is the gravitational acceleration shown with negative g. So now we can write down the kinematic equations for horizontal and vertical motions. Okay, so note that this equation is the same as this equation. The only difference is that v average is replaced by vx because the velocity along the x-axis is constant and it's equal to vx. Now I'm going to write down the kinematic equations for the vertical motion. So here, the first equation is the same as this one, and it's only that x is replaced by y, x0 is replaced by y0, and v average is replaced by this expression. The second equation is the same as this equation, and it's only that v is replaced by vy, v0 is replaced by v0y, and a is replaced by negative g. The third equation is the same as this one, and again, x replaced by y, x0 replaced by y0, v0 replaced by v0y, and a replaced by negative g. And as you can guess, the same thing with this final equation. Also note that Vx is the same as V cosine of theta, and Vy is the same as V sine of theta. This is because if this is the velocity V and this is the angle theta, this is essentially making a right triangle here, where this would be Vx and this would be Vy. And we know that in a right triangle, cosine of theta is equal to the adjacent side divided by hypotenuse, and sine of theta is equal to the opposite side divided by hypotenuse. So that's why we end up with these two expressions for Vx and Vy. And the only common variables between these two motions, the vertical motion and horizontal motion, is the time t. Because even though the object is moving independently in x and y direction, but it's essentially the same movement happening at the same time. So the only element these two motions have in common is the time t. So after solving each motion separately, we then recombine them to find the total displacement and velocity. So let me write down the equations for total displacement and velocity. And if you're wondering where these equations came from, again, it's because we have a right triangle here. This is x, this is y, and this is the total displacement s. And we know that the Pythagorean theorem says that the hypotenuse is equal to square root of each side squared summed up. And again, the same thing with the velocity. It also makes a right triangle. This is the total velocity, and each of the sides of this triangle represents Vx and Vy. Also for the angle, we know that this is theta, and this is theta V, or the angle of the velocity with respect to the x-axis. And we know that in a right triangle, tangent of theta is equal to the opposite side divided by the adjacent side. And the same thing for the angle of the velocity with respect to the x-axis. Let's look at an example. Let's say we have a ball that is kicked into the air with initial speed 17 meters per second and at an angle 75 degrees above the x-axis. So the velocity, initial velocity is 70 meters per second, and the angle it makes is 75 degrees. We want to know what is the highest point the ball can reach. How much time is passed between when the ball was kicked and when it reached the highest point? And what is the horizontal displacement during this time? To solve this question, first thing we need to do is to break down the motion into horizontal and vertical motions, where the acceleration in the x direction is 0 and in the y direction is negative g. We define the initial position to be at the origin of the coordinate system, so we can take x0 and y0 to be 0. So this is my coordinate system, and I start at the origin. So x0 is 0 and y0 is 0. To find the highest point of travel, we need to focus on the vertical motion. Since we don't have the time, the best equation to use here is this one. The highest point in any trajectory is reached when Vy is 0. This should be very intuitive, because when the velocity is 0, then there is no more speed that would cause the object to move any further. So that's the highest it can get. So to find out what is the highest position that the ball can get, we need to find out where the velocity is going to be equal to 0. So using this equation, we are going to set Vy to be 0, and we know that g is negative 9.8 meters per square second. We know that y0 is 0, and we want to find y. So the only thing that is left is v0y. What is v0y? From here, we know that Vy is equal to V sine of theta. So to find V0y, we're going to say this is equal to V0 sine of theta. And now we can solve for V0y. Now that we have v0, y, and we have everything else, it's time to find y. Note that this expression, y equal v0y squared divided by 2g, which can also be written as h equal v0y squared divided by 2g, with h being the maximum height, is valid for any projectile motion where air resistance is negligible. So whenever you have a projectile motion question and the question wants you to find a maximum height that the object can reach, you can always use this equation to find a maximum height. Now let's find the time. Here's the easiest equation we can use to find the time. Note that we could also use this equation to solve for t. And if we use this equation, we get the same answer, but it would make our job a little bit harder because if we use this equation, we're going to have to solve a quadratic equation to find t. Okay, now that we have the time and we have the highest point the ball can reach, all is left is to find the horizontal displacement. To find the horizontal displacement, remember that the motion along the x-axis is a constant velocity motion, since there is no acceleration in the horizontal direction. So we can use this equation. We know that x0 is 0. We already found time. Time is 6.9 seconds. All we have to do is to find Vx, and then we can substitute it here, and then we can find x. And with this, we have found the maximum height the ball can reach, the time it takes for the ball to reach that height, and we found the horizontal displacement of the ball. I hope this video helped you understand the concept of projectile motion. If you have any questions, ask me in the comments, and don't forget to subscribe so you don't miss my next video on relative motion.